Oh, good morning, or good evening, or good afternoon. Good morning. Boop, boo, doo, 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 doo. Okay, this is Mr. P signing in. It's good to have you all here. Today we're going to be looking at our guided notes for section 11.2, areas of circles and sectors. So the sector of a circle is a region bounded by two radii of a circle and their intercepted arc. That is, if an arc was just a part of the circumference of a circle, like arc AB, think of arc AB also outlining what's called a sector of the area, just a piece of the area of that circle P, like that. So the area of a circle is pi times radius squared, where r is the radius of the circle. Perhaps you remember that from 7th grade. And so it makes sense that the area of a sector would just be the portion of that radius. That is, so if the area of a circle is pi times radius squared, then the area of the sector is going to be what portion of 360 degrees that arc is over the 360 times pi r squared. Well, let's take a look here. So the formula for the area of a circle, let's talk a little bit about where it comes from. You could divide a circle into congruent sections and rearrange the sections to form a figure that approximates a parallelogram. I want you to notice that it won't actually make a parallelogram, but it gets awfully close. And that's this thing down here. Like if you imagine slicing this up into a whole bunch of little triangle-ish, like pizza pie slices. Phew, excuse me. I just sneezed on a math help video. Okay, then you can imagine rearranging them here to like make some kind of cool looking monster. See the little cyclops eye and little crazy teeth, like rah, rah, rah. Anyway, so the base of the parallelogram of the figure is half of the circumference because that's half of the half of this. It's really, you could imagine that's what happens when you take these pieces and arrange them down there, and that the height is the radius. The height is the radius of your circle. So that h equals r. So the area of the parallelogram is base times height, which is 1/2 times the circumference, which is pi times the radius, which is the height, and that gets you pi r squared. Just kind of a little idea of where that comes from. So if we're going to find the area of circle M, first we need to find the radius. That is way too big of a pen. There we go. So, and the radius is half of the diameter, which is given to us as 5. So the radius is 2.5, which means that the area is equal to pi times the radius squared, which in this case is pi times 2.5 squared. Now 2.5 squared is 6.25, so the area is equal to 6.25 pi centimeters squared, which again, depending on what object we're talking about, may or may not be terribly helpful. So you might want to do 6.25 times your calculator's version for pi, 19.635, about 19.635 centimeters squared. Not too bad. What about the area of a circle with a radius of 6.1 yards? So again, the area is equal to pi times the radius squared, which in this case is going to be pi times 6.1 squared. Now 6.1 squared is going to be 37.21. So the area is equal to 37.21 pi yards squared. And I'm saying that because there's the exact area where you actually have the pi in there. So honestly, in order to get that, all I did was just do 6.1 squared and then glue a pi onto the end. Did the same thing over here when I did 2.5 squared, just glued a pi onto the end. Again, that's not very helpful if you're talking about how much lawn you're looking to do. So if you're asking someone to mow your lawn and they say, well, how many square yards is it? And you say, well, I measured it and it's exactly 37.21 pi yards squared, my good friend. They're going to think you are crazy. And so we're going to go ahead and multiply that by pi. And now you can tell them it's about 116.899. You know what? I'm going to call that 116.999. yards squared. That's what I would tell them. It's about, I'd honestly say it's about 117 yards squared. Round it up and leave it as a tip. Why not? What about the diameter of a circle with an area of 10 square feet? Now, this is going to change up on you. That means that the area 10 equals pi times some unknown radius squared. So to solve for r, we're going to divide both sides by pi. And bear with me while I do 10 over pi equals the radius squared, which means that I'm going to take the square root of both sides, which means the radius is equal to the square root of 10 over pi, which I'm not going to lie, I'm going to leave just like that. There's not really much you can rationalize. Oh dear, that's not what I wanted to do at all. Okay, and that was feet. Again, people are going to think you are not okay if you go around telling them that, oh yeah, how far across is my swimming pool or my hot tub? It's the square root of 10 over pi feet. So we're actually going to do 10 divided by pi, which is about 3.183. So the square root of 3.183 feet. We're going to take the square root of that number so that this comes out to be about 1.784 feet, which I am regretting my hot tub example because I have just said that you have a hot tub that is 1.784 feet long across, which is not quite 2 feet, and that is the most claustrophobic hot tub I've ever heard about. No thanks. A radius of a circle with an area of 65 square centimeters, that is, the area, 65, is equal to pi times the radius squared. So we do the same thing we did before. Divide both sides by pi. So r squared equals 65 over pi. Take the square root of both sides, and you get r is exactly the square root, and I'm going to make that a square root of the whole fraction, the square root of 65 over pi. And that is, centimeters, excuse me. Again, not something that's terribly helpful. So we do 65 divided by pi. 65 divided by pi, which is about 20.69, and then take the square root of that, and you get 4.549, about 4.549 centimeters. That's how I would answer it. The radius is exactly the square root of 65 over pi, and it's about 4.549 centimeters. One of the reasons that I'm not actually distributing this root into both the numerator and denominator is that you'll notice that the integer amount is not a nice root, and there is no hope of rationalizing the bottom when you've got a pi down there. There's not really anything you can do about it as terms of rationalization. Now, the area of the sectors. So this is the thing, is that now we're going to find the area of this whole circle. Let's start with that. So the whole circle is area equals pi times radius squared, which is pi times 4 squared, which means the area of this circle is 16 pi centimeters squared. Now that's the area of the whole thing, but notice that we're only talking about this section that I'm outlining in blue here. And this section takes up 140 degrees out of the 360 degrees that are the entire circle. So 140 over 360 divide by 10, so we can reduce by 10. Also, those degrees divide out, and that's going to give me 14/36 reduced by 2, and I'm going to get 7/18, I want to say. Yeah, 7/18. So it's 7/18 of the circle, which means I need to take the area of the whole circle, 16 pi, I'm going to multiply it by 7/18 because I'm only taking 7/18 of the circle. Now that means that this will divide by 2, or you could think of that as cross reduce, so that'll be 9, 8. Not much you can do about that. So we've got 8 times 7, 8 times 7. Oh, why is that 8 times 7? Okay, I'll write that out. 8 times pi times 7/9 is what I'm looking at now. I'm going to switch the order there. So now it says pi times 8 times 7/9, and let's change that to pi times 8 over 1 times 7 over 9 and multiply straight across. And 8 times 7 is 56. So I get 56/9 pi centimeters squared, which again, that is not the kind of number that most people are expecting. So that's the exact area of the sector, which means the approximate area, we're going to do 56 divided by 9. We're going to multiply that by pi, and we're going to get about 19.548. 19.548 centimeters squared is the approximate area of that sector. Cool.